Talk about another measure which is called Gini impurity or Gini index, which is also for measuring the randomness or impurity in a given attribute, and then helps to select the best attribute with respect to which we can split the data and kind of divide the tree. So it's like creating a decision node. So we take the same example, and then on which we applied the entropy earlier, and then we apply the Gini index on this. So the formula is a little bit different, and we want to tell you that Gini index is used to, it was kind of introduced or used to measure the extent to which distribution of income among individuals or within a household in a particular economy, within an economy, deviates from a perfectly equal distribution. So we assume Gini index assumes that the perfectly equal distribution will be equal to 0. Gini index will be 0, and Gini index will be 100 if it's a perfectly unequal distribution, a complete inequality. So the formula of Gini index is 1 minus sum of I equal to 1 to n pi square. Okay, so here is the probability of occurrence of a particular class is pi here. So in general, in the very basic form, Gini index applies to a binary classification where yes, no, two categories are there. So here we want to show you that for the same problem where there's a left node and right node, which is coming from dividing this based on age, if you remember, and then we are trying to see that what will be the Gini index for the left node, for the right node, and for the parent node. Okay, so in the Gini index for the left node will be 1 minus probability of the positive samples squared plus probability of the negative samples squared. Okay, so it's 1 minus 3 over 7 which are positive, and then 4 over 7 which are negative. So then we get 0.49, then which is very close to the 0.5, which is, if you remember, for a binary classification case, this means that the equal number of samples from the positive and the negative classes. Okay, so similarly, when we do this one, the right node, we do equally, so 3 over 5 and 2 over 5, then we get 0.48. Now again, we do it for the similar kind of thing for the parent node, which has like 6 and 5 samples, so it's 6 over 11 plus 5 over 11, and they are all of them, you can see they're very almost close to equal number of samples, so they're very close to 0.5. Okay, like they were close to 0.9 or almost 1 when we did the entropy, because they are very almost equal number of samples. So I deliberately chose those. I'll explain when I explain that graph. Okay, so now we do the weighted combination of the left and right nodes, and we see that 7 over 11, that because there are like total like 7 samples among the 11 samples which are in the left has total like 3 plus 4, 7 over total 11 samples, and here we have 3 plus 2, 5 over 11 samples. Okay, is it 5? Okay, so it should be 5. 7 over 3 plus 4, 7. Anyway, so you can see that the weighted combination now becomes like, when we add them up with the Gini index, and we get 4863, which is a little bit less than the parent node's Gini impurity index, which is 0.49. It shows that when you go down, that means you split from using this parent node, then we go down. So our objective is to lower the Gini index. So that means this split is good. So similarly, we'll calculate the split with respect to the other attributes like the BMI and alcoholic or not the person, that and then we'll find out that whichever gives the lower Gini index when you split with respect to it will be the best. Now, one thing I want to show you that here, this is a graph where we are plotting both entropy and Gini index, and we can see that it varies from 0 to 1. 0 means one way pure sample, like all are negative, we consider 0, and all samples are positive. That means absolute purity, it's a single class in one group, and then it's 0, it means all negative, 1 means all positive, and this is kind of the variation. Okay, the 0.5 is the highest probability, and where the means that equal number of samples almost equal number of samples will be close to 1, 0.5 is the exactly equal number of samples, and the entropy is 1. Okay, so the maximum amount of randomness. Similarly, at exactly that point when there are equal number of samples, Gini impurity index will be half. You see 0.5. So Gini impurity index varies kind of half of the entropy, and that's why we consider Gini impurity index as a kind of a better measure. Another reason is that Gini impurity index is computationally more efficient than entropy. Sometimes the logarithmic items takes longer time to compute than the Gini impurity index, which is just plain straight square of the probability. And so sometimes Gini impurity index is computationally more easier or less resource consuming. That's why it's preferred by many more algorithms. In the here it should have been one extra sample. If we want to tally it, there's 6 negative samples, 6 positive samples. I added one more negative sample here, so the parent node now becomes 1 minus 6 over 12 plus 6 over 12, and then this gives half square is 0.25, another half square, so it's like exactly 0.5 there, because it's an equal number of positive and negative samples. So it's a maximum impurity or maximum randomness. And then you can see 0.5, and then the weighted combination of the left and right children 0.4863, which is definitely less than 0.5. So we are kind of reducing the impurity. So this is a good split. And similarly, I'll also do it for the entropy. On the entropy of the parent node here with that correction, where now we have 6 negative samples. So you can see it's a perfectly mixture, 50% of positive sample, 50% negative sample. For a binary classification case, it will be, that's a very impure. And now it's minus 6 over 12 log of 6 over 12, and same another for the negative sample, and log half is basically minus 1. So then when we multiply, it gets 1. So you can see from this graph, 1 is the case where we have the maximum impurity, the entropy is highest. So you have to remember that entropy varies between 0 and 1, or entropy is maximum of 1 when there are 2 classes. Entropy is can be from 0 to 2 when there are 4 classes, and in that way it can increase. But Gini impurity index normally varies from 0 to 1 for a binary classification case, but it can be extended by the pairwise comparison, and we can discuss it later. Thank you.